Good morning, everybody, and welcome back to Next Door NetAdmin. Today, I thought I would show you a little bit of what I've been working on more recently, which is an OPNsense HA setup. HA in this case, highly available, is just having two routers, two OPNsense, that are going to work cooperatively to manage the network, such that if one drops out, the other one will just pick up where the other one left off and keep going. So this is going to be demonstrated in a Hyper-V environment. And there's a couple things to set up first. Number one is you need to make sure you have at least 3 interfaces, because you're going to want your external and internal, and you want a dedicated interface for your HA peer link, your sync. So you need to make sure that you have that. The WAN and the LAN both need to have advanced features, and you need to enable MAC address spoofing. And the reason for this will be covered as we go through this, but on the external and internal interfaces, you need MAC address spoofing. You do not need that on the HA sync line. So that's what you need. So let me show you what I've got set up here. The primary router, and you'll notice, yes, one is primary router, and I've got that in a dark theme, and I've got my secondary router in a light theme, so that I can always tell which one is which just by looking at it. And this is an absolutely basic setup. There is nothing particularly complicated about it. I have not customized anything in the dashboard. This is installed straight from the ISO. I have not done any software updates. I have not done any plugin installations. Nothing. This is just as it comes. But I've set it up in HA, and I'm going to walk you through the various parts to the setup. So let's start with interfaces. The assignments for these interfaces, pretty basic: external, LAN, and HA, and that's it. Now, the WAN address, I'm going to assume that 10.10.38.1 is my gateway. Okay, cool, fine. And in fact, now that I'm looking at it, that really needs to be set with the WAN gateway in mind. Whoops. All right. But why is this .3? Normally, wouldn't the address be .2? The address will be .2, but the .2 address is going to be shared between both of the OPNsense boxes. So if I go to my secondary router and go to the same thing, it is very important that the same identifiers be on the same interfaces. So if WAN is WAN, LAN is LAN, and HA is opt1 on both, then we're good. So if you have more interfaces, you just need to make sure that the identifiers are on the same interfaces, and you'll be fine. So WAN, I just need to go in and make sure, yep, okay, that should have the WAN gateway there. Probably didn't because I've been futzing with it. And this is .4. So if this one is .3, this one is .4. And the same is going to be true of the LAN as well. The primary is going to be 192.168.1.2, and this one will be 1.3, because 1.1 is going to be the address that they share between the two of them. And then for the HA link, this is just 172.16.32.2, and this will be 172.16.32.1. And I've just made it a /30 because it only needs to be a link with 2 addresses between the 2 OPNsense units. So with that in mind, the first thing to set up, honestly, is probably a firewall rule. So let me show you that first. It's this rule here. This rule says on the HA interface, allow all of the traffic. All of the traffic. Because it's only a line that goes between the two. When I've actually set this up in physical reality, it's just a single Ethernet cable. It's not even going through a switch. It's just a single cable between the two. This is going to be used for 2 things. One is pfsync, and pf in this case is packet filter. This is what allows the 2 firewalls to synchronize the state of the firewall, packet filter, in real time. As traffic goes through the primary router, it's going to update the secondary router with the record of what traffic has gone through, so that if the primary router goes away, the secondary router, when it steps in, will understand that traffic has been sent, and it'll allow the return traffic back through. Seamless. The second thing that's going to happen over the HA link is XMLRPC. This is an on-demand synchronization of the configuration from the primary to the secondary router, not the reverse. pfsync will go both ways, because if the secondary router is taking over because the primary is rebooting or something, when the primary comes back online, the secondary router also wants to update the primary router with the contents of the firewall. But as far as configuration sync goes, it's only going to go one way, from the primary to the secondary. It's on demand, not continuous, because we want the opportunity to change the configuration on the primary. If something's gone wrong, we want the secondary to step in again without the configuration having replicated over to it in a broken state. So it'll only ever replicate on demand, and that's a safety measure. The other thing that I added to the firewall rules is this top rule here, which says for the LAN and WAN interfaces, we're going to allow the CARP protocol. And the reason for this is because CARP is what allows our floating IP address to be synchronized and move between the 2 units. We will get to look at that in just a moment, but for now, yeah, that's the other firewall rule that's required in order to make this work. Allow everything on the HA link, and then allow CARP on the WAN and LAN interfaces. So then if we look here under System High Availability, these are the settings that we expect to see. And I'm actually going to bring this up on the secondary firewall as well, so that we can compare the two. So we're going to synchronize all states via the HA link. The compatibility, this is 24/7 or above. The peer IP address is the other side of the link. So because the primary is .1, I'm going to synchronize to .2. And the reverse is true here on the secondary. For pfsync, we're going to synchronize via the HA link, and we're going to synchronize to the primary IP address. Everything here is blank because this is the secondary firewall. It's only going to receive configuration. It's not going to send it. On the primary system, we're going to put in same IP address to synchronize the config. We're not going to verify the peer because this will verify the SSL certificate. There's no need to do that over a single cable link. And because we're synchronizing via an IP address, it wouldn't match the certificate anyway. And if you're using just the out-of-box certificate, it's not going to link to a publicly trusted root, so the out-of-box certificate isn't going to work if you do this anyway. But then the remote system username and password, okay, cool. And then what services we want to synchronize. Currently, I have this set up for aliases, firewall rules, NAT, and virtual IPs, and that's basically it. But there's many other things that you can synchronize between these, not that you always should. For example, you can synchronize certificates and authorities, but each unit should probably have its own certificate. Let's say, for example, you have a single domain name that points to the floating IP address and you want it to be vpn.company.com. Okay, that's fine. But each unit has its own domain name. So the primary unit will have primaryrouter.company.com and vpn.company.com. The secondary router will have secondaryrouter.company.com and vpn.company.com because they each have their own IP address as well as the one that they share. If you synchronized certificates and authorities, the primary system's certificate would replicate over to the secondary, and that's not what we want. Those should be renewed independently. So I'm not going to synchronize that, but the capability is there. Same for things like DHC relay or DNS mask or your Kia DHCP server. All of these can be synchronized depending on what you want actually to replicate between the units. But if we're looking at just a basic minimum, this is probably a good minimum. Aliases, firewall rules, NAT, and virtual IPs, and that will help keep the most important things in sync for sure. If we then go to status, we can see that the primary router can see what the firmware is, what the base and kernel is on the backup firewall, and then it can see all of the services running on the backup firewall as well, the secondary router. And if we hit this button to synchronize and reconfigure all, it will copy all the configuration for the services that we are replicating, and it'll copy that from the primary router to the secondary router and actually put that into practice. If we tried to check settings on the backup, well, the backup firewall is not accessible because this is the backup router. We haven't entered any credentials for it to talk to a target to replicate its configuration, because this is the one we only want to receive. So you'll get nothing when you look at status. Now, how about those floating IPs? That'll also be in interfaces. It'll be under virtual IPs. And then we'll see the two floating IP addresses that we have set up here. 192.168.1.1 for LAN and 10.10.38.2 for the WAN connection, assuming that 38.1 is actually going to be the gateway on the ISP side. These are both CARP IPs. If we would go to add in one, you can do IP alias or you can do proxy ARP, but these are specifically mode CARP. And then you see a VHID group. CARP essentially creates a shared virtual MAC address that is being it's what the virtual IP address is attached to, is a virtual MAC. The VHID group is part of the MAC address so that you can have multiple CARP groups on the same physical broadcast domain, but you can keep them separated so that you can have multiple CARP IPs in there. In OPNsense, if you want, you can add an IP alias to the interface as well, but you would definitely want to attach that to the CARP virtual IP address. And if you do that, there's special ways of configuring the IP alias so that it works properly with CARP if you're adding it to something that's already been set up. But this is just basic, so we're just demonstrating what we've got here. If I go to status on the primary firewall, we can see that this is currently the master for both of these. That means that these addresses are currently owned by the primary router. And if I go to interfaces, virtual IPs, status on the secondary, the status is currently backup. And you'll see these two buttons, temporarily disable CARP and enter persistent CARP maintenance mode. Both of these will essentially cause the primary router to voluntarily relinquish its control. Current CARP demotion level is 0. If I temporarily disable CARP, CARP is no longer allowed. The status is switched to disabled, and if I refresh the status over here, it's now master. These addresses now live here on the secondary router, and that switchover would be completely transparent to any client devices using 192.168.1.1 as the gateway. And then when I re-enable CARP, it starts as backup, but it will resume its master role, and this will resume its backup role. Easy peasy. If you hit temporarily disable CARP, it doesn't last through a reboot, however. But if you enter persistent CARP maintenance mode, then it actually continues to run CARP, but demotes itself to a much lower priority. And the result on the secondary will be the same. It will become the master. But persistent CARP maintenance mode allows you to reboot the unit, and it will still come back up as the backup instead of resuming the master role. This is important if you're going to do something like update firmware. If you're going to update the firmware needs to be kept in sync on both of them. So what you do first is you enter CARP maintenance mode on the backup, on the secondary router, do your firmware update, reboot, and then you can update the firmware on the primary unit, and you're going to have to reboot it, and it will fail over to the backup at that point. But it won't be able to do so seamlessly because they were out of sync firewall versions. But it's a single brief interruption that way when you're doing it rather than multiple interruptions. There is a procedure for doing this that OPNsense has put in the documentation. If you're going to do it, I strongly suggest looking at it to actually go through it and familiarize yourself with the procedure ahead of time, because I don't know that I explained it very well there. The last thing that you need to do, and that I haven't done on these units yet in this simulation, is you need to adjust your outbound NAT, because by default, your outbound NAT is going to use the WAN address, but the WAN address is not 10.10.38.2. As it stands, the WAN address for the primary router is .3, and on the secondary router, it's .4. So you need to create a new NAT rule that says, okay, for the WAN, everything that's going outbound, any source, any destination, instead of the interface address, you need to change this to your CARP external address, which in this case is 10.10.38.2. And when you do that, save it, also see how you have this option here, no XMLRPC sync. If you check that, this configuration will not be replicated when you do a normal replication for NAT. But I actually want that, so I'm not going to check that option. But there you go. WAN any, we're actually going to NAT this to 10.10.38.2 rather than the actual WAN address, which is .3. And If I go over to the secondary firewall and take a look at my outbound NAT, I don't have that here. I don't have that rule here. But because I have my high availability configured with NAT as one of the things that I actually want to replicate, if I synchronize and reconfigure all, when it's finished, because it'll take a few moments because it has to restart all of those services, once it's done, I'm going to go back to the secondary router, refresh the rules, and we should see the outbound NAT rule replicated right there. So that on the secondary router, if that's taking charge, rather than natting everything to .4, everything outbound will continue to NAT to 10.10.38.2. This is done now, so when we go over here, and I don't see a refresh button, so I'm just going to refresh it manually. There it is. We've created the NAT rule on the primary firewall, and then replicated it to the secondary, so that no connections should drop if you have a cable pulled or if one of the units goes down. The secondary will be able to continue going through it. So there you go. That's the basics for setting up an HA sync within OPNsense. And this is something that I'm not anticipating necessarily doing for a lot of customers, but it's really, really useful when you have somebody who needs that extra guarantee of uptime such that they don't mind getting 2 different units for it. And, I mean, there's always the possibility that you could do something interesting, like having a physical box for one router and a virtual box for the other. As long as they can talk to each other on all of their interfaces, then you should be able to make that work. In a virtual system, you'll need to enable MAC spoofing because, like I said, CARP uses its own constructed MAC address. And so in a virtual system like Hyper-V, it'll treat that as a spoofed MAC address. It's not the one that Hyper-V assigned. So that's why you have to enable that for any interface that's going to run CARP. The gateway, same on all systems. There is one thing that I will mention that I didn't remember to mention previously, which is when you are setting up your CARP virtual IPs, the subnet mask must be the same as what you have on the interface. OPNsense makes note that some documentation says you can set a virtual IP as a /32, and it will appear to work, but you'll get errors on things like your DHCP servers because it's not constructing it properly when it actually goes to use it. Something I have done, we're using a /29 on the WAN. What if your ISP only gives you a single external IP address? It's part of a /30. Something I have done and is not recommended at all by OPNsense, but as an example of things that you can do if you want, you can set up your WAN address using private IPs, just like I've done here. You can set it up with a /30. The primary router at .1 on this private IP address on your WAN interface, and the secondary router at .2. And then your CARP, I didn't say it had to be part of the same subnet. I said it has to have the same subnet mask. If you have your one single external IP address as a /30, while the underlying interfaces have a real MAC address that's private, it will work. But only one firewall can communicate outbound at a time, which means only one firewall can pull updates If you're using intrusion detection, if you're using XenArmor content filtering, if you are doing anything like that, it can only get updates when that floating IP address is on that unit. Certificate updates, again, will only work if that unit has the public IP address, and you'll have to swap it back and forth manually in order to be able to update the units. That's really not a great idea, and it's not as designed. It will work, but it's fragile, we'll say. So, very much not recommended. If you do that, keep in mind that gateways as configured will go from the actual real MAC address on the interface. And that won't work if you're trying to ping 10.10.38.1, but your actual real MAC address is 192.168.35. Whatever. If that's the case, you might need to go in here and set the option for a FAR gateway, which all that means is it allows the gateway to exist outside of the interface subnet. When it's a FAR gateway, as long as you have the 10.10.38.2 floating IP address on this unit, the gateway will be reachable. And when it's not there, the gateway won't be reachable. You just have to tick the FAR gateway so that it'll allow it to be there without it being the same subnet as what's on the actual interface itself. Okay, now I think I've showed you everything that I need to show you for a basic functioning HA setup. Hopefully you found that interesting. Hopefully that's something that's useful to you. If you have thoughts on other things that you would like to hear me talk about or things that you would like to see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.